This problem asks us to prove the following. Let D be a commutative ring with unity. Prove that D adjoint X is a principal ideal domain if and only if D is a field. Okay, so in the backwards direction, we're going to appeal to some stronger facts. Since D is a field, we know that D adjoint X is a Euclidean domain, and also every Euclidean domain is a principal ideal domain. So D adjoint X is a PID. Okay, so we appeal to two other results there. And now let's do the forward direction. So in this direction, we uh, suppose D adjoint X is a PID. So note that D adjoint X modulo the ideal generated by X is isomorphic to D. So by the correspondence theorem, the ideals of D adjoint X modulo the ideal generated by X correspond to the ideals of D adjoint X containing the ideal generated by X. And since we can identify D adjoint X modulo the ideal generated by X with D, this means that ideals of D adjoint X containing the ideal generated by X correspond to ideals of D. And we remember we want to show that D is a field. So um, what we need to show that the only ideals of D are D itself and the zero ideal. All right, so let's think about ideals of D adjoint X containing X. So um, since D adjoin X is by assumption a PID, any ideal containing X is generated by one element. So let the ideal generated by A be some ideal containing the ideal generated by X. Um, okay. So X is an element of the ideal generated by A, which means that um, A divides X. So A times something is going to give us X. A times something in D adjoint X. And well, the only two ways this can happen are if A is, right, A can't have degree higher than 1. So either A could have degree 0, but then it still has to be a unit because it has to be able to multiply by something and get X. Or it could have degree 1, but if it has degree 1, its coefficient still has to be a unit because it has to multiply by something to get 1x, or just x. Um, so so either A is a unit, and if it's a unit, and then the ideal generated by A is equal to the adjoint X itself, the whole ring, or um, A is equal to UX, where U uh, is a unit of um, D, or equivalently D adjoint X. And um, in this case, the ideal generated by A is equal to the ideal generated by X. So the only ideals of D adjoint X containing the ideal generated by X are the ideal generated by X and all of D adjoint X itself. And remember, those ideals correspond to ideals of D. So there are only two ideals of D. So, well, we know that there always have to be two ideals, namely the improper ideal and the trivial ideal, right? So the only ideals of D are the improper ideal and the trivial or zero ideal. And this is equivalent to um, for D, a commutative ring with unity, to D being a field. And that proves the forward direction.